Hi, everyone. My name is Robin Matthews. I'm part of the Expedia Worldwide Engineering Organization, and I'll be talking about my team's journey towards Aurora. So before we get started, in this presentation, I'll be talking about a lot of different database technologies and why it didn't work for our particular use case. But I want to caveat that those same technologies are very actively used for very different use cases in different parts of the company, and they work perfectly fine. So with that caveat, let's get started. I'm guessing most of you have heard of Expedia, but for those that haven't, we are one of the largest travel companies in the world. To give you an idea of our size, last year we did more than $50 billion in gross travel bookings. We have a broad range of supply across different lines of businesses like flights and hotels, and we also have a large cross-section of brands and websites across different parts of the world that generate a lot of demand for us. So a little introduction of my team. So we call the Lodging Inventory Services, or also known as the LIS team. And think of us as sitting between a service layer, sitting between our hoteliers and Expedia. So Expedia provides a lot of tools, depending on the type of hotel. If you're a small hotel or big hotel, you get different tools. And the hotels use those tools to actually work with our marketplace, right? Update rates, inventory, availability. And all of those tools actually go through the LIS service layer before those updates make it into our marketplace. I have some of my team members here in the front row. So Anil, Jeff, and How, do you want to quickly stand up? So in case you want to talk to us about our journey later, we'll be around for maybe 10, 15 minutes. You can swing by. So let's talk about the use cases. At a high level, I would put it in two categories. One that I call finding the needle in the haystack. So a good example of this is dispute calls that we get from our hoteliers. So occasionally, a hotelier, typically during invoicing time, they might give us a call and say, hey, we think you booked our room at the wrong rate. It should have been $150, but we see that you made the booking for $100. We need data, historical change data, to kind of prove or disprove their statement, right? So we have tools today that can actually pull up everything that happened to a room rate, and we can tell the hotel in very minute detail what exactly happened. So in this case, it's quite possible that the hotelier was kind of right because they did, around that time, make that rate update to $150. But guess what? Maybe the commit happened 2 seconds after that booking. So we're able to show them that, hey, yes, you changed it to $150, but guess what? When the booking happened, it was still $100. And they're happy, we're happy, right? So that's one use case. So it's really looking for those specific records in a huge swath of data. And unlike the image over here, they're not going to wait for 65,000 seconds, right? So they really need that response pretty quickly. The second use case is what we call value-add features. So an example of this would be, hoteliers wanting to know what the guy across the street is doing in terms of their pricing their rooms, right? So we would want to give them information, historical trends, maybe even future stay dates, like what is their competition doing in the next week? How are they manipulating their rates? So again, we need this change data that I was talking about to be able to generate those trends and share with the hotel. So now that I've talked about those use cases, I want to give you guys an idea of the size of the data we're talking about here. So any guesses from the audience on how many changes we see in the Expedia travel marketplace on a typical day? Any guesses? Several thousand? Much higher. Any other guess? Sorry? 1 million? Close. So we do roughly 300 million updates a day, and this is a typical day. We might have a busy day, maybe several of our big partners are doing full refreshes, and we could see like 1 billion plus updates happen on a single day. Now, if you think about the use case I mentioned earlier, right, about having that dispute resolution, typically we want to keep this data around for 2 years. So think about that, 300 million updates a day, keep that data around for 2 years, ideally, right? And obviously, we want to do this at minimum cost. And we also want super fast response times when we're querying that data. So before we talk about the different solutions we looked at, I want to spend a little bit of time on what we use today, right? So all of the stuff that I described, we are actually doing today, and we have a SQL Server infrastructure that supports it. It worked very well for us back in the day, even until a few years ago, but as our data size has grown, it started, as all of you here using SQL Server knows, it's really hard. So we've done the typical things like, we've used tier 1 SAN for fast I/O. We have obviously partitioned and scaled out, so we're able to scale out. But it is not as easy as AWS, right? Nothing is happening, nothing is elastic or automatic, right? You have to keep an eye on it and do it yourself. And the cost. If you think about licensing, the hardware, storage, especially the tier 1 SAN, the cost tends to get really high. So one of the first things we looked at was Cassandra, along with Apache Solar. So the reason we started off, we thought it would work well with our use cases, and we had a couple teams in Expedia that had some success with this. But one of the issues we ran into, because of the type of querying and response time needs that we had to have a lot of indexes, not just one or two. And what we saw is that as our data size grew, the Solar indexes got really huge. And that would have meant we needed a lot more hardware in our Cassandra ring, adding to the cost. So it was not that viable for us. And this is around the time we started exploring AWS. And we started with MySQL. And we started really simple. We went with JPA, no provisioned IOPS, no table partitioning, single inserts. And we got a performance of roughly 400 inserts a second. We did some of the basic tuning. We used JDBC. We started doing batches. We provisioned IOPS, and we were able to increase the performance significantly to around 5,000 inserts a second. But what we saw is that we were bottlenecked at that after around 300 million rows. And the other thing was, I talked about the amount of data. MySQL supports just 6 terabytes of storage, and that certainly wouldn't have worked for us long term because our data was growing by leaps and bounds. And like I mentioned earlier, we need to store, ideally, the 2 years' worth of data. So this was around the time Amazon introduced Aurora. So we had a portion of the team tinkering with it. We were able to use a lot of our learnings from MySQL and port it over. And right off the gate, we saw much improved performance of about 25,000 writes, inserts a second, with peaks of up to 70,000. This was with one month's worth of data. And our reads and writes were super fast as well. So I guess in summary, the early results look promising. We've already started migrating the 2 years of data that I'm talking about, and early results show that the performance continues to stay similar as our data size is growing. And the other thing that works for us is 64 terabytes, right? So I think that covers us for some time. I mean, we can definitely migrate, do 24 months of data, and then our data is growing as well as we add more and more hoteliers. So we should be able to, this should sustain us for the near future. So I guess, in conclusion, what I would say is that you really need to think or really understand your use cases in detail before you can kind of narrow down a database solution that might work for you. But even after that, I think until you actually put your real data through those systems and try it out, you're really not going to know how it's going to perform for you. So that was, I guess, the lesson learned for us. And hopefully, you guys in the room can take a little bit out of that. So that was it from my side. Thank you.